So that's what we're going to try to do. We're going to measure it, and I brought a measuring tape. So who would like to use the measuring tape to measure the length and width of those louvers up there? Anybody? Who brought their wings? So we would like to use some mathematics to help us measure those things, and actually I'm going to give it away. They're 28 feet long, but how wide are those louvers, and how can we use a little bit of mathematics to figure out the width of those louvers? Any suggestions? Okay, so if we could get the length of one of these rectangles, then that would be a start at least. We start to make progress. So how would we measure the length of one of these rectangles? Okay, well, I get the suggestion we can measure from this column here on the ground along this line to that column there, but, well, that's some distance in the ground. How would we know it's the same as the distance up there in the air? It's a rectangle, right? And so we can use the mathematical property that the rectangle formed by going up the column, across the rectangle at the top, down the column, and back along the ground has opposite sides equal in length. So if we measure the length down here on the ground, we are in effect using mathematics to measure something we can't even reach. So let's do it. I need a friend who's going to put the end of that measuring tape right against that column over there. You may have to go sort of, yeah, exactly, get that chair out of the way. Let's go underneath the table. Perfect. I'm going to measure to here, and I get, looks like just under 24 feet. And now you're going to have to put it right on that glass. Okay, and I get just over 24 feet. So how long are these rectangles? 48 feet, excellent. That's a nice round number, so that's working pretty good. So now how are we gonna get the width of the louvers now that we know that the rectangles are 48 feet long? There's no, there's only 3. Oh, here there's 11. But they're kind of angled. Are you sure? Like 11, how does 11 help? I actually like the 11 number. It looks to me, I don't know if it looks to you, if we took the ones that were directly overhead and if we could rotate them so they were all lying perfectly flat, they would just meet. So I think we're in good shape here. These would just meet, and so the spacing between the connections where they're connected to the wall should be equal to the width of the louver. So now how do we go and get that spacing between the connections on the sides of each of these louvers? What would we do? Okay, so I hear divide, and I hear divide 48 by 11. Is dividing 48 by 11 the correct thing to do to get the width of the louvers? Okay, so what we said is the width of the louvers is going to be equal to the spacing between 2 of those connections. And there are 11 connections. If we divide the 48, the length of the rectangle, by 11, does that give us the space between 2 of those connections? Let's make a diagram. When in doubt, make a diagram. So I have my trusty dandy whiteboard and whiteboard marker here. And let's do a simpler example. I've got a rectangle. Let's do the 3. The 3 is nice. If I have 3 louvers, will the spacing between each of those connections be 1/3 of the entire rectangle? No, why not? Right, because 3 lines create 4 spaces. So how many spaces do 11 lines create? 12, so how wide is each louver? 4 feet, 48 divided by 12. So it came out nice and simple, which is often a clue that you're on the right track when numbers come out nice and simple. And you'll see some good examples of that later on when we can talk about creating math tours, how simple numbers often tell you you're on the right track.